Problem 3-24. Look back at the expressions in problem 3-23 that are not equivalent. For each pair of expressions, are there any values of the variables that would make the two expressions equal? Justify your reasoning. So I brought the problems from 3-23 back up here, and we concluded that A was not equivalent, E was not equivalent, and F was not equivalent. That doesn't mean that the expressions can't end up being equal, though. When we look at letter A, we're talking about the quantity of x plus 3 squared and x squared plus 9. So what we're trying to do here is we're trying to think of, is there a value that we could plug in for x that would make these two expressions equal each other? And indeed there is. There's a couple numbers with some special properties that, when you're adding or when you're multiplying, sometimes end up making things seem equal. For instance, in this case, we know that the value 0, when we add it to anything, is going to end up causing it to equal itself. That'd be the addition property, the identity property of addition. So if we look here at plugging in 0 for x, we would say 0 plus 3 squared. Well, that's the same thing as 3 squared. And when we square 3, we end up with 9. So we know that the value of that would be 9 when we plug in 0 for x. If we do the same thing here, if we plug in 0, we'd say 0 squared plus 9. Well, 0 squared is 0, and when you add 0 to 9, you're going to get 9 also. So just because the two expressions aren't equivalent, we do end up with equal values there when our input value is 0. So yes, on letter A, we could say the expressions are equal when 0 is input into the function. Sorry, I tried to write too fast there. So the expressions are equal when the input is 0. Let's try looking at letter E. Letter E, we had x to the third raised to the fourth power. And we were talking about x to the seventh. So when we do this one here, we're going to look at, this is just repeated multiplication over and over and over. And once again, there's some numbers that have special properties when it comes to multiplication. In this case here, if we plugged in 0 and multiplied it times itself over and over again, we would end up with 0. So if we plugged in 0 here, we have 0 to the third power. And we're raising that to the fourth power. Well, 0 to the third power is 0 times 0 times 0, which is still 0. And when we raise that to the fourth power, it's still going to leave us with 0. So 0 is going to work for us. And that's the same thing as saying 0 to the seventh power. Oops, so there we go. Bear with me. There we go. So 0 works. And we also could throw in 1 into this. We could say 1 to the third power. And to the third power. And then we could take it and raise that to the fourth power. Let's just fix that real quick. All right, there we go. So we have 1 to the third is going to be 1, and then we raise it to the fourth power, so that would give us 1. And we know that 1 to the seventh power is still going to be 1. So in this case, yes, the expressions are equal when the input is going to be 0 or 1. And then I think there was one more, letter F here, that we wanted to check on. In this case, we have two different variables, so we have to think about that. If we go ab squared and a squared b squared, so we have a b squared. Sorry, my pen is starting to act up and do its own thing here. This is strange. Come on. There we go. And we have a squared b squared. So think about it in this case, you know, the same properties will apply if we have, you know, a, let's say if a was 1, if a was 1, then it really doesn't matter what b is here, because if we did a was 1 over here, we would end up with 1 times b squared, which b could be any number there. And if we did a here as 1, we would have 1 squared, which would give us 1, and that would still be times b squared. So in that case, it didn't really matter what b is. If a is 1, that will work. And if we went ahead and put in something like 0 for a, right, wouldn't that also work? Because if we had 0 times b squared, we had 0 times b squared, whatever it was here, because 0 squared would be 0, and times b squared would still leave us with 0 no matter what. So it doesn't really matter what b is, as long as a is not 0 or 1. Then they will end up being, they'd be different if a was not 0 or 1. They'd be the same if a was 0 or 1. So yes, the expressions are equal. If a equals 1. Or 0, sorry. Geez, jumping ahead here. There we go, or a equals 0. Alright, that would have been the only 3 that you really needed to look at there, because the other ones, because they are equivalent, they would equal the same thing no matter what values you put in. That's the difference between when they are equivalent and not equivalent. Alright, this is problem 3-24. If you have additional questions, please make sure you ask your teacher. Thanks for watching.